Hi there. So this is about the selective consumption of the messages by different consumers. When I say a consumer, I mean a service provider consuming messages of the EMS queues, of the same EMS queues, but with different contextual information. So here we have a service consumer and a service provider, which is and the service consumer is sending messages or one particular queue to be consumed, for those messages to be consumed by the different service providers. Now these service providers may exist at the same time and consume their respective messages which they recognize and find relevant to consume, or they might come in existence at different intervals of time and consume their respective messages and go away. So this is the idea behind the selective consumption. And here we have a business workspace service consumer or a message producer sending messages to the EMS, and as a part of second step, these messages are taken off from the EMS queue based on what is the source value. So if it's SRC1, it is consumed by service provider 1. If it is SRC2, it is consumed by service provider 2, and if it's SRC3, it is consumed by service provider. So and we have only, just for simplicity sake, we have kept only one service consumer which is sending the message. So here is that consumer, and if you see so here is the what we call GMS application properties in BusinessWorks, which is used to set up the contextual information, and we have only one property here, which is source, and it's of type string, and it can be optional as well. So when we send that message, we just simply send the value of source to SRC1 in this particular publisher. Here is SRC2 and here is SRC3. So parallelly we are sending three messages over a same queue. Queue is just the same, which is this one. Consume totally stuff to one. Okay. If you see here, this is the same queue, same queue. Okay. So this is your EMS message producer or service consumer. And then we have the actual consumers, message consumer or service providers, which are now selector based. So we have delegate or delegation mechanism based consumers, which are of course asynchronous consumers using selector mechanism, and it takes in the selector and then consumes the message selectively. We have still listener based mechanism consumer, which is again selective, and we have synchronous consumer, which is very selective. So here in this we have set the message selector as source is equal to source 1. So in this configuration, if I run this particular example, with source resourceful, it will only pick the messages which have their source field in the properties set as social. So let me go to this output directory. No, not. It's April 23rd and it's morning of April 3rd, early morning of April 23rd, and you can see Google has been created. And so now let's run this one. I suppose I think this is the best one. And first of all, let me start the EMS if I have not yet started it. Consumer, as you can see, and let me see the queues for the so this is the queue. We have got 0 receivers and 0 users. So here some changes have been made in this library where I brought in a new class called access message consumer, which has a few constructors or two constructors, and which will take the two basic parameters, queue name and number of sessions, and another one takes these two parameters and of course the vectors as well. And this simply assign the number variables with the supplied values. So every IFS message consumer or every consumer should now belong to this class or should inherit from this class, and if it is synchronous or it's asynchronous, so that these variables can be taken up, and if you want to do any coding at this level, at the highest level, you have some data available to code for. Okay, so it's just to reduce redundancy and maximize reusability. So this class has been introduced, and here you can see that create consumer is now been brought up, where you have the loop and all the message, all the session and queues and the consumers can create it for asynchronous consumers. Same could not be done for synchronous ones because of certain peculiarities. So maybe I'll see and try to fix that to be able to bring that those functionalities, synchronous functionalities, here somewhere at the top. Okay, so this is where, you know, if the message selector is not null, then you have to create a consumer with the message selector, or you simply create the consumer with only in the queue or the destination, and then you do the things specific to the asynchronous message consumer or the listener-based message consumer or the delegate-based message consumer, where, you know, you just simply assign the event handler of the message arrival notifier to the message handler, never function of the message consumer. And in case of listener-based, you just simply assign the message listener to the defined object, and this object must be deriving from or extending the iMessage interface. So that's few things that's been done, and it's been done to, you know, to at least minimize as much as possible the redundancy which could be seen downwards in these two respective classes. Okay. And then, of course, for formality's sake, you know, this has been brought here at the top too. Okay. So this is the one class which has been introduced. Okay. So now and then accordingly the coding has been done in this class, where, you know, these are, you know, inheriting from the iMessage message consumer, and then of course these two interfaces for the listener-based consumers, asynchronous ones, and then the various constructors of these consumers which are passing on the supplied variable to the top constructors of the class, of the message consumer class. Okay, so and it's quite self-explanatory to see that. And then the delegate one, which only inherits from the MS system. It's a delegate-based mechanism, so it only, you know, and then the assignation of the message handler is done at the top, and that particular handler method can be, you know, derived or it can be overridden in the derived class. So this one can be overridden in the derived class. This is the client, or this is the area where the developer comes in to create the consumer by extending the consumer of the classes, variable classes. So let's take this one for example, and this one is the consumer, and this one obviously extends from this class, and which in turn extends from the IFS message consumer class. And of course, the two interfaces, and here you can see this one. This process only relates to the upper class, and this one is overridden and just simply in a process message like that. So let me try to first. Yeah, this is the one, and let's see if this is start. Yeah, so if you see, I'll just put some rattle in here somewhere which shows that the message selector is source equal to source 1. So if I send messages from this, only these messages will be consumed, and this will be lying on the queue, this queue. Okay. And what is the other messages? Other messages is where the other messages? Yeah, it's 4. So since there are 3 permission, so in all 9 messages would be sent on a same queue but with different source values. Okay. So the fire is there are 5 receivers which are these are 5 receivers. Okay. If you can see this one, this is your evening acknowledgement mode, which is a client acknowledgement, and F-mode selector. So this stuff means it's having some selector. Okay. And this means what? I forgot. Yeah, and the consumer is started. It's acknowledgement mode, and this SSD is consumer has a selector. So it's plus, so it has a selector. So no messages have been consumed, and these all 5 consumers are looking for messages on this queue with source equal to source 1, all 5 consumers. Okay, so now if I send the message, there will be 9 messages sent in total over 3 iterations of the loop, and 3 of which will be consumed, and rest 6 will be saved. So now let me see, 3 have been consumed of 5. Okay, and if you see the queue, 6 messages are still remaining. Okay, that's 9, 3 have been consumed, and 6 messages are still remaining. And if you see here, so the 5 threads are there, and 3 are used in consuming the 3 messages that we sent. And if you see here, this one, source SRC1, SRC1, SRC1. So 3 threads are used up, and for consuming. So, but we still have 6 messages, and 3 each of which are having values SRC2 and SRC3. Okay. So what we can do is, we can go there, change the value of SRC1 to SRC2, save it, kill this one, and rebuild it. Okay. Or you can change the values where in the config file in the bin directory, so that you need not rebuild it. So now it's built again, and now it should go into the same queue to look for values. But now it will consume it all over again because those three messages are remaining on the queue, and we will not fire another message or another iteration of this particular instance before all the messages get consumed, just for simplicity's sake. Okay, so yeah, so hold on. So this is source 2, and you can see that it happens so quickly that the threads, they are fighting for writing space on the screen, and so there has been some interleaving flows there. So that's what it is. So source 2. So now if you see here, so out of 6, 3 have been consumed and 3 have remained. Okay. So and this of course 3 have been consumed. So these threads will be wasted because I will be killing it, and so that I can change the configuration to source 3 and restart it, so that source 3 messages also get consumed. Okay. So now let me rebuild it. There you go. So source 3, and if you see here, so queues, there is no message remaining. So before it was 3, and before 3 there was 6. Okay, and when 9 messages were sent, it of course, as soon as the 9 messages were sent, I could not get the time to run show queues because the consumer was already started for source 1 and it consumed the 3 messages for source 1. And the 6 was so that's the thing about 3 message consumers running one at a time and selectively reading off their messages of interest. Okay. So the selective consumption is based on a SQL-like syntax where you can use source equal to source 1, source 2, source 3, or you can also use something like source like src. So if the pattern matching is satisfied with the value contained in the source field, it will put that message up. So if I put source like source here like this, it will pick up all the messages which are having values like source 1, source 2, source 3. So let me see how it is. So there are 5 receivers yet. Okay. So there is no message for this queue, and there is only one consumer, which is that of administration 2. So let me put this and rebuild this and restart it. Okay, so here you can see the source like this one. So it will, if I fire this, so it should consume all the messages. Okay. And let me see the consumers. Yeah, the 4 all consumers, and they all have selectors. Yep. Now let's fire this off. no message from the PDF. Okay. So let me first do this and let me fire that. So all will be lying on the queue. So we can see there are 9 messages. So there are 9 messages. Yeah. And so it will go down. It will just go down. It will take time. So now I start them again. So all of the consumers, of course. So if you see now, these are all of consumers. So 9 messages. First 4 threads are consuming 2 messages each, and last one has 1 message remaining coming its way. So this is what the selective consumption is. You can use the selector as a syntax, as a SQL-like syntax, to choose the messages that you want and then make it the messages that you want. So that's pretty much it. You can go to the code. It's already uploaded on the Bitbucket, and so you can share it with you. And then probably you can see what we can do about the questions. They're pretty simple, and it's quite simple and self-explanatory, I would say. So that's pretty much it, I think. You have seen that. So any questions?